All right, here's our pulley, and it has a mass that we're going to call capital M and a radius that I call little r. And it's got a weight hanging from either side. This one is M1. This one is M2. And M1's smaller than M2, so the whole thing is going to rotate this way. So the first thing that we have to do is draw some free body diagrams for the two hanging masses. So let's do that. We've got, for M1, we've got M1G pointing down, and we've got tension number 1 pointing up. For this one, M2, we have M2G pointing down and T number 2 pointing up. And we can write equations for each of those. They only have vertical components, so we're only going to get one equation out of each. This one gives us T1 minus M1G, and that's going to be equal to a positive M1A because M1 is going to go up. This one is T2 minus M2G, and it's going to be equal to minus M2A because M2 is going to go down. So those are our two equations. We can't use this to calculate the acceleration because we have two equations and we have essentially three unknowns. There's T1 we don't know, T2 we don't know, and the acceleration we don't know. So we're going to need one more equation. And to get that equation, we're going to go to a torque equation. So the torque equation comes from the pulley. There's the pulley, and we have a number of forces acting on the pulley. First of all, we have the weight of the pulley, which is going straight down. We use a capital M for the mass of the pulley times gravity. All right, that's acting on the center of mass of the pulley, which is right in the middle. There also has to be something holding the pulley up. It's not drawn in the picture, but there has to be something holding the pulley up. And it's probably holding it, well, that has to be holding it right in the middle. Otherwise, the pulley won't rotate right. So there's the force of whatever's holding the pulley up. Now, we have the two tensions, one here and one here, right? This one over here on the left is tension number 1, and it's pulling down because that's the way the string goes. And this one over here is tension number 2. So when we start doing our torque equation, we choose the center of rotation, and then since this thing is going to rotate, we want to choose the actual center of rotation. So our center of rotation is going to be here. Now, if that's the center of rotation, that eliminates both of these as torques because they have no lever arm because they're acting on the center of rotation. So that means only these two forces have lever arms. So there's the lever arm for this force, which is the radius of the circle. And here's the lever arm for that force, also the radius of the circle. Now we check our angles. The radius is always going to be perpendicular to a tangent, so this is 90, and so is that. So we're ready to write the torque equation. Remember, the torque equation for something that is accelerating is of the form torque equals I alpha. So we're going to find the total torque by adding up these two torques. Now, this one on the left is making it rotate clockwise, and the one on the right is making it rotate counterclockwise. They need to be in opposite directions. And since it actually is going to rotate, I'm going to take the direction that it actually rotates as being the positive direction. So this T2 torque is going to be positive, and the T1 torque is going to be negative. So I'm going to say RT2 minus RT1 for the total torque. Remember, radius, force, sine of the angle between them, and the sine of 90 is 0. So that's the total torque, and that's going to be equal to I alpha. Well, we know since this is a solid disk that I is equal to 1/2 mr squared. We know since the rope is not slipping on the edge of the pulley that the tangential acceleration A is equal to alpha r. And if we plug those both in there, we get RT2 minus RT1 is equal to 1/2 mr r squared a over r, which when you simplify that, you get t2 minus t1 is equal to 1/2. Oh, I just realized I used the wrong symbol. This should be capital M for mass, capital M here. So this is going to be 1/2 capital M A. Now using this equation and these two, solve that one for T1, solve that one for T2, you can plug those into here and you can calculate the acceleration.